It's important to remember the blanks method. You're going to be filling in the little blanks. It's really powerful in one way, especially. If things can repeat, you have to use blanks. You can't use any other way. All right. This problem actually you don't repeat people. Like you can't have the same person bat first and second and third. That'd be kind of fun, but you couldn't do it. But when you do have repeating things, like if I could have a license plate, can't license plates have like the same letter in it twice? Yeah, and if it can repeat like that, you can't use permutations because it'll be like 12 times 11 times 10, and you need the number to stay the same. Like all the letters are possible is 26, times all the letters are still possible is another 26, times all the letters are still possible is another 26. All right, so if you need it to repeat like that, you can't use P's or C's. All right, so the blanks method is handy in a couple ways. So in this case, the team has 9 members, but the coach does not want the pitcher to be one of the first 4 to bat. So the pitcher cannot be in those choices. So I don't have 9 choices for my first one. What do I have? Times 7 times 6 times 5. And then all of a sudden I can put the pitcher in. So it should normally go down to 4, but it goes back up to 5 times 4 times 3 times 2 times 1. And these are all being multiplied in here, and there'd be your answer. You get that? If you multiply choices. All right. Next one, 9 people in your class want to be on a 5-person bowling team to represent the class. How many different teams can be chosen? That sounds like a P or C thing. Which one is it? C, because the order doesn't matter. So it's 9C5. All right, next one, cards. I've actually got a whole problem on cards that I'm going to show you next that's better. And then this last one. As soon as they said expected gain in this problem, I knew what they were talking about. What kind of a problem is it? Expected value. And in a life insurance situation, what you need to know about, it's not like a warranty where somebody, like it breaks or it doesn't. With a life insurance, it's like the person dies or they don't. Okay, so this is kind of grim, but they would be live or die. P times A, then add them all up. And the probability of living for this guy is 0.993. And they actually have this. They have probability of you living. It's on a big chart. Right now, some actuary, that's what they're called, can look up and find the probability you're going to die this year. They have that for every age person. Okay, they use that to set life insurance rates. They do a lot of complicated things to figure it out, but basically, think of it this way. If you know how many kids your age last year died, then you can figure out the probability you're going to die, right? Except they also factor in things like, don't you think some kids that live in like Bolivia might have a higher chance of dying than, or wherever, it's Haiti, heaven forbid, you can have a higher chance of dying than here. So it depends on where you live. It depends on your sex. Boys don't live as long as girls do, for instance, etc. But actuaries are the ones who come up with these numbers like I circled there. But you can come up with this number, 007, because you know these together have to add up to 100%. So just a reminder, expected value, you do probability times the amount, and then you add them all up. The amount he gets if he lives is nothing. In fact, he loses the $150 he spent on the life insurance, and here he gets the $15,000. Actually, he doesn't get it. He died, but his family gets it. All right. So you might say, well, why doesn't somebody take out a big life insurance policy like right before they're about to die? Because the insurance company won't give it to them if they know that they're sick. You have to prove that you're still healthy. And some people try to game the system by taking out a life insurance policy and then killing themselves so that their family can get a whole bunch of money. But the sad part is that the insurance company won't pay them. So it doesn't work. That's correct. They will not pay if you kill yourself. I should clarify, I think some policies will not pay if you kill yourself in the first certain number of years. That's kind of a grim thought. But I thought there was some kind of like, in the first 2 years, they can look at any death like super close with a fine-tooth comb to make sure that the person didn't do something weird. Or even worse, the spouse didn't do something weird, because every now and then a spouse takes out a life insurance policy on their spouse, their husband or wife, and then the person suddenly dies, like unexpectedly. And then, ooh, I guess I got to collect this $1 million life insurance policy. And of course, who's the biggest suspect? Whoever took out the life insurance policy. All right, I just think those are kind of interesting, so I thought I'd talk about it for a second. This one would be binomial because it's got a simple 80% chance and it doesn't change. So it's 80% and then 20%, and then you could say, well, I got these 4 seeds, and I want at least 1 to germinate. But this brings up a good point. At least 1 means 1 or 2 or 3 or 4. What does or mean? Add them all up. So if either 0 are going to germinate, or 1, 2, 3, or 4, I can either, all these add up to 100% possibility. So either I can add up all of these, or, remember this? Subtract from 1. If they all add up to 1, I figure out the probability that none of them germinate, and just subtract that from 1. So if I'm going to figure out the probability none are going to germinate, I have 4 seeds. None are going to germinate. 80% chance they're going to germinate, and I want none. 20% chance they're not going to germinate, and I want 4. You'd figure out that one and subtract from 1. All right, there's a lot of things to remember on this, isn't there? Okay, what is the probability that more than 2 will germinate? Well, that means 2 or 3. That's just simpler to just do 2, probability of 2, and then probability of 3, and or means you'd add them together. So 4 choose 2 to germinate, 2, 2, or 3 to germinate. Or means add. Yep. So find them each and then add them. Yes? 3 or 4. Yeah, there's 4 seeds that are out there. So, all right. If it said more than 2, oh wait a minute, does it say more? Oh, more than 2. It should be 3 or 4 that I should have done, not 2 or 3. Sorry about that. Sorry, I did the wrong one. So I don't want to redo all of that, but if it was going to be more than 2, then I should have done 3. 3, and then this would be 1, or 4. Sorry. 4 and 0. Okay, that's fixed. The last one's actually the easiest one. Probability that exactly 2 will germinate. Well, then you just do the same thing except you just do 1. You just say 4 of them choose 2. 0.8 to the 2, 0.2 to the 2. All right, now let's move on. Remember how I said blanks were good for if you have to repeat something? Here's one. How many license plates can they get in Minnesota? There's 3 letters followed by 3 numbers. I remember my first car was the Fez 470. FEZ 470. That was my license plate. My first car. And now that helps me remember that there's 3 letters and 3 numbers. Okay, so you would use what technique for this? Because things can repeat. Blanks. Got to use blanks. How many choices first one? 26. How many second one? Third one? How many numbers? 10. Common mistake is 9, but you can use 0. So there is 10 and 10 and 10. And I multiply them all together, and that's all the possible license plates that it could be given out in the state of Minnesota. And it'll end up being millions. 17 million? Okay, sounds good. There are some license plates that get thrown out, some bad words that they don't want to spell and that kind of stuff, but generally that's how many license plates there are. Okay, moving on. This is a typical card problem that's been set up. Remember, 52 cards in a deck and choose 5 if you get dealt 5 cards. Is this ringing a bell? You remember these? And then this would be like if I wanted 4 aces and there's 4 aces in the deck and I choose 4 of them, and then there's 48 other cards in the deck and I only want 1 of those. Does that ring a bell? And then what could you do at the end of these to make sure you've done it right? Don't just do it on the calculator. What I mean is you can look at your setup and know if you set it up right. You remember this? Yeah. What do? Those add up to 52. And these add up to 5. Exactly. If they balance like that, you did it right. To see if you understood that, I want you to try this one. I am going to be doing the same exact 5-card game, except this time I want all clubs. Figure out the probability that I'm going to get all clubs. Yes, there are 13 clubs in the deck. You are correct. if I want all clubs. Now, if you're stuck, just do the parts you know. I bet you know that it's, since there's 5 cards, it's 52 choose 5. Time running out?